Hey guys, in this video we are looking at finding the length of a line segment. So, in the previous video in this playlist, we looked at finding midpoints of a line segment. Here we are finding the length of them. So, a little recap. First of all, there is a very subtle difference between a line and a line segment. A line is a straight line that goes on infinitely. So to represent a line, we can draw a line with these little arrows pointing away on both ends. So with this red line here, the little arrows are telling us this line goes on forever up and to the left and forever down to the right. So it never stops. Whereas the second guy in blue is a line segment. It joins up 2 points. So it starts at A and ends at B. So it has a finite length. Whereas just a line has an infinite length because it never stops. It doesn't have a start, doesn't have an end. So line segments join 2 points together. Now these 2 points we can call the coordinates x1, y1 and x2, y2. Sometimes you might see them written as xa, ya and xb, yb. Either one is fine, does not matter at all. So in the previous video we looked at finding midpoint coordinates. Now a midpoint is, for once, exactly as it sounds, it's the point exactly in the middle of a line segment. So a line has no midpoint because it has no start and end, but line segments do. Now the formula for the coordinates of a midpoint is x1 plus x2 over 2 and y1 plus y2 all over 2. So to find the midpoint coordinates, you add the corresponding coordinates together and divide by 2. So you're finding the mean of each set of coordinates, basically. So hopefully you're familiar with that. Now we are looking at finding the lengths of line segments. So there is a formula, but instead of just giving it to you, we're going to derive it. So here's our line segment. Let's call this point A and this point B. And we're going to say that A has coordinates x1, y1, and B has coordinates x2, y2. Now then, we want to find the length of this line segment. Now it's nothing drastically new. In fact, it's not really new at all. We are just applying something that we have been doing for years. If I was to draw a dashed horizontal like that, and then a dashed vertical like that, what have I just created? A right angle triangle. So, what we now need to do is recognizing a right angle triangle, we are now playing Pythagoras. So as long as the line segment is a sloped line, it's always going to be the hypotenuse of a right angle triangle, in which we can play Pythagoras. So we just need to work out how to express the vertical height and the horizontal length in terms of the coordinates. So the height is just going to be y2 minus y1. And then very similarly, the horizontal length is x2 minus x1, like that. Okay, so using Pythagoras, if we call this guy L for length, then we know L squared is x2 minus x1 squared plus y2 minus y1 squared. Then all we need to do is square root. So L is the square root of x2 minus x1 squared plus y2 minus y1 squared. So there's our formula. It's just Pythagoras, but it looks a bit more complicated. So let's work through some examples. Example 2. So here we have point A has coordinates 1, 0, and B is 5 minus 10. So I would recommend labelling your coordinates. Now it doesn't matter at all which ones equal x1, y1 and x2, y2. Doesn't matter, but they do have to be a matching pair. So I'm going to label them like this, and my length is going to be the square root of 5 minus 1 squared plus, now I have to do minus 10 minus 0. So minus 10 minus 0 squared. Okay, so we've got the length is the square root of, well, 5 minus 1 is 4. 4 squared is 16. So we got 16. And then over here, minus 10 minus 0 is minus 10. Square that, you get positive 100. So we get 16 plus 100, like that. So the length is the square root of 116. Now, with this guy we can simplify that certain bit, and it's very likely you would be asked to do so. So, it's good practice. So, root 116 is not very nice. We could write this as root 2 root 58. And then we could write that as root 2 root 2 root 29. So that then finally is 2 root 29. Jobs again. Okay, example 3, we're getting a little bit more problem solving here now. So we want to find the length of this segment of the line y equals 3x plus 1 that connects the axes. So, what does that mean? Well, let's first of all make a sketch. So, I'm going to draw our axes in for this one. Now, 3x plus 1 is going to look something like that. So, we know this line has a gradient of 3 and a y-intercept of 1. So, straight away, if we zoom in, we already know that the y-coordinate of this point is going to be 1, and we actually know, because it's on the y-axis, that the x-coordinate is 0. So, what we need to do is find the coordinates of this point down here. Now we know the y-coordinate is going to be 0 because we're on the y-axis. Sorry, we're on the x-axis, so the y-coordinate is 0. We just need to find the x-coordinate. So to do that, we're going to change colour. So we know on this line at this point on the x-axis, y is equal to 0. So we're solving 0 equals 3x plus 1. So minus 1 equals 3x. So minus a third equals x. X equals minus a third. Okay, so now we have our coordinates. So it's going to be an incredibly short length, but that doesn't matter. So the length is going to be square root of 0 minus 1/3. So that's just going to be 1/3 squared. 1/3 squared is 1/9. So we got 1/9 plus 1 minus 0 squared, so it's 1. The 1 squared is just 1. So we've got the square root of 1 and 1/9, which is the square root of 10/9, which we can write as root 10 over 3. Job's given. Okay, last one here then for this video, so we're putting everything together for this one. So a line segment has a gradient of 3/4, a length of 5, and midpoint 2, 3. We want to find the coordinates of each end. So let's draw a sketch. So we know this segment has a positive gradient, so it goes up from left to right, like that. Now, we know that the midpoint, let's call it has coordinates 2, 3, and I'm going to call this end A, and say that the coordinates are x1, y1, and then this point, the other end, x2, y2. So there's a sketch of what's going on. Now we also know the length is 5. So we are going to use these 3 pieces of information to form and solve some equations. It's a really tricky question, so go nice and slowly through it. Bear with me. Okay, so first of all, the gradient is 3/4. Now gradient is difference in y over difference in x. So we know y, get my pen out, we know y2 minus y1 over x2 minus x1 is 3/4. Now what we're going to do there is multiply through by x2 x minus x1. So we will get y2 minus y1 is equal to 3/4 x2 minus x1. Now you're going to see why we've done that in this next bit. So we also know that the length is 5. So that tells us then that x2 minus x1 squared plus y2 minus y1 squared square rooted is equal to 5. Now, if we square both sides of that, I'm going to cheat a little bit so that I don't have to write that all over again. So if we square both sides, square root sign disappears, and we end up with 25 on the right hand side. So what we will notice here is that we have a y2 minus y1 term here, which we also had up here. So we're now going to play substitution. So we're playing simultaneous equations. So we are now going to substitute in y2 minus y1 equals 3/4 x2 minus x1. So we will now get x2 minus x1 squared plus, now this is all going to be squared, so 3/4 x2 minus x1. Now that is all going to be squared, and that is all equal to 25. So if we now sort out that big square bracket, we've got x2 minus x1 squared plus, now 3/4 squared is 9/4, so 9/16. And then x2 minus x1 all squared is x2 minus x1 squared. And that is all equal to 25. Now, we need to combine this left-hand side. I'm aware this is a really horrible question. Hopefully you're following it through alright. We need to combine our left-hand side then into one term. So we've got one whole lot of x2 minus x1 squared, and then 9/16 of x2 minus x1 squared. Now this whole lot of x2 minus x1 squared we can think of as 16/16 x2 minus x1 squared. So now we can add 16/16 of that, add 9/16 of that together. So we've got 25/16 x2 minus x1 squared, and that is equal to 25. Now this is really nice. We can square root both sides. Now everything there is a square term. So if we square root both sides, we now get 5/4 x2 minus x1 is equal to 5. Now if we multiply both sides by 4, 5x2 minus x1 is equal to 20. And then finally, if we divide through by 5, x2 minus x1 is equal to 4. Crikey, that was a lot of work. Now we haven't finished, but we have definitely done the trickiest bit. Okay, so now remember that the midpoints had coordinates 2, 3. Now we can get an equation for our x coordinate using that. Remember, midpoint coordinates are given by x2 plus x1 over 2. Now we know that that is equal to 2, which tells us x2 plus x1 is equal to, if we multiply 3 by 2, is equal to 4. So now we have two equations in terms of x2 and x1. They are simultaneous. So if we now call this guy equation 1, this guy equation 2, both of them have the same amount of both letters. One has a negative x1 and one has a positive x1. So if we add those together, so if we do equation 1 add equation 2, we get 2x2 is equal to 8. So x2 is equal to 4. Now from that we can work out the coordinate of x1. So we know x2 plus x1 is equal to 4. Now we know that x2 is 4, so therefore x1 is equal to 0. So up to here we now have our x coordinates of each end of the line. So we now know this is 0 and this is 4. So now we just need to find the corresponding y coordinates. So we're doing a very similar thing now for the y coordinates, but nowhere near as much work, thank God. So remember the gradient y2 minus y1 over x2 minus x1 was equal to 3/4. We now know x2 minus x1 is 4 minus 0. So y2 minus y1 over 4 is equal to 3/4. Therefore, y2 minus y1, if we multiply 3 by 4, is equal to 3. So now we just need to use the midpoint y coordinate to get another equation. So y2 plus y1 over 2 is equal to 3. So y2 plus y1 is equal to 6. So we now have our two equations for y2 and y1. Just move this up here. So it's simultaneous equations again. Let's call this 1 and this guy 2. We can add them together. So we will get 2y2 is equal to 9. So y2 is 4.5, and then finally we need to find y1. So 4.5 plus y1 is equal to 6. Take away 4.5, y1 is 1.5. There we go. What a question. So let's just put those in after all that work. So we got 1.5 here and 4.5 up here. Okay guys, hope you found that useful. Monster of a question there at the end. Good fun though. Okay, take it easy. Take care.